Welcome to Daily Papers, the podcast where we break down the latest fascinating research.
Today, we're heading to the very edge of our solar system, way out past the orbit of Neptune. It's a vast, cold, dark region filled with icy bodies left over from the birth of the planets.
These are called Trans-Neptunian objects, or TNOs for short. You've definitely heard of the most famous one, Pluto. And we're looking at a paper that tackles a really fundamental question about them. Why do they come in different colors?
It sounds simple, but it's a huge debate in astronomy. Are these icy worlds born with their distinct colors, or is it something that happens to them over billions of years? It's a cosmic nature versus nurture argument.
And this paper uses a really clever new tool, a type of artificial intelligence, to act as a detective and finally solve the case.
So, to set the scene, astronomers have noticed that TNOs aren't all the same. Some are quite reddish, while others are a more neutral grayish color. This has led to two main theories about where those colors come from.
Okay, what's theory number one?
Theory number one is the primordial model. Primordial just means from the very beginning. This idea suggests that TNOs get their color from where they were born. Billions of years ago, the disk of gas and dust that formed our solar system wasn't perfectly mixed. Different areas had different chemical ingredients.
So a TNO that formed in one part of the disk would be made of slightly different stuff and have a different color than one that formed somewhere else. The color is like its birth certificate.
Exactly. But then there's theory number two, the evolution model. This theory suggests that maybe the TNOs all started out looking pretty similar, but their appearance changed over time.
Evolved, you might say. What could change them?
A couple of things. One is collisions. The outer solar system is a bit of a cosmic demolition derby. Over billions of years, these objects can crash into each other. A big impact could scrape off the old weathered surface and reveal fresh, different-colored ice from underneath.
Another possibility mentioned in the paper is irradiation, basically a form of space sunburn. The constant stream of particles from the sun could slowly tan the surfaces of these objects, changing their color over time.
So the big mystery is, are the colors a memory of birth? Or are they the scars of a long, hard life in space?
And this is where the new paper by lead author Benjamin L. Davis and his team comes in. They decided to tackle this without using traditional complex physics simulations. Instead, they turned to AI.
Specifically, a technique called causal inference. We're all taught that correlation isn't causation. For example, sales of ice cream are correlated with shark attacks. They both go up in the summer. But buying ice cream doesn't cause a shark to attack you.
Right. The hidden cause is the hot weather, which makes people both swim more and eat more ice cream.
Causal inference is an algorithm that tries to figure out these exact relationships. It looks at a pile of data and tries to determine the direction of the arrow. Does A cause B? Does B cause A? Or is there a hidden C, like the hot weather, that's causing both?
So what data did they feed this AI detective?
They gave it the stats for 229 TNOs. For each one, they included its color and its orbital parameters. That means things like eccentricity, which is how stretched out or oval-shaped its orbit is, and inclination, which is how tilted its orbit is compared to the main plane of the solar system.
And they just let the algorithm go, with no preconceived notions about how the solar system works. And the first thing it found is just incredible.
It is. As a sanity check, the model looked at the relationship between the stretched-out orbits and the tilted orbits, and it concluded that there must be some large, unseen object out there whose gravity was influencing both of them.
It found a hidden cause. Let me guess, was it Neptune?
It was Neptune. The AI, without ever being told that planets exist, essentially rediscovered Neptune just by looking at its gravitational fingerprints on the orbits of these smaller objects.
That's amazing. It's like a detective realizing a key suspect is missing from the case just by looking at the evidence left at the scene. It proves the method is reliable.
Exactly. So, with their method validated, the researchers turned to the main question. What is the relationship between a TNO's color and its orbit?
If the evolution theory was right and collisions were changing the colors, you would expect a chaotic, tilted orbit to be the cause of the color change. The arrow would point from inclination to color.
That's the logical conclusion, but it's not what the AI found. The model concluded with 98.7% certainty that the arrow points the other way. It found that a TNO's color causes its inclination.
Hold on. How can a color, which is just a surface property, cause an entire object's orbit to be tilted? That doesn't make physical sense.
You're right, it sounds strange. But the key is to remember what the color really stands for in this model. It's a proxy or a stand-in for the TNO's birthplace.
So what the model really found is that the birth location determines the orbit. Objects that formed in a certain region of the early solar system got a specific color and were set on a path that would eventually lead to a more tilted orbit.
Precisely. The color and the orbit are both effects of the same original cause, where the TNO was born. This means the color isn't a recent change. It's a fundamental primordial property.
So the primordial theory wins. The colors of these distant worlds are a genuine fossil record, telling us about the chemistry of the solar system more than 4 billion years ago.
That's the conclusion. The paper strongly rules out the idea that collisions or irradiation are the main drivers of TNO color. The colors really are their birth certificates.
What a fantastic result! And it's not just what they found, but how they found it. Using this kind of causal AI to solve a problem in astrophysics is pretty groundbreaking.
It really is. It's a powerful reminder that we can make new discoveries not just by building bigger and better telescopes, but by developing smarter ways to analyze the data we already have.
An AI that can look at data and rediscover a hidden planet is a powerful tool to have in your back pocket.
Absolutely. It opens up a whole new way of investigating the universe.
And that's all the time we have for today. Thanks for tuning in to Daily Papers.